I'd like it to, give me a sec. Trying to get it to not mirror. Oh, this is going to be a pain. I did a run through the other day, and it kind of let me see the next slide and stuff like that. And there we go. Yeah, I got it now. Cool. Can people see this? Is this good? Can I read it? All right, cool. So yeah, I'm going to talk about progressive web apps today. My name is Dom Farolino. Here's a oversized picture of my head for all you guys to see. This is the first presentation I made with Keynet, so I just kind of threw the picture in and it blew it up, and I thought it was kind of cool. I'm Dom Farolino, pretty much anywhere, GitHub, Twitter, yeah, Slack, whatever. I'm a third-year computer science major at the University of Cincinnati and an executive member of the ACM student chapter. I see some of the other students here and the executives, so thanks for all coming. Basically, here's a quick little roadmap of what I want to cover today. We're going to talk about progressive web apps, and when giving this kind of a talk, it's really simple to just dive right into progressive web apps, or really tempting to dive right in and talk about the details and how to build them and what's a service worker and what kind of code am I going to have to write. But I think to get a better understanding of the need for progressive web apps, we have to start with talking about native versus web. So right now, people are choosing native a lot. I mean, not only developers, but also consumers. And notice this isn't like native versus mobile web or mobile native versus mobile web or anything like that. I mean, we're talking about native applications, desktop applications and things like that that have been around since the desktop has kind of been born. And so the idea of a native application has kind of shaped what we think of as an app in many different ways. And so we generally have a set of expectations that an app should bring to the table. And we expect it to be able to easily integrate with native hardware, access to native hardware. We expect applications to work and load offline because the way the app model works, we download it, then we install it. It's going to be there regardless of the network connection, stuff like that. We expect it to have on mobile some sort of push notification integration, or at least the ability to, and on desktop like some kind of integration in the native event system for the operating system. And of course, we expect it to be on the home screen, the desktop, the app tray, start menu, all kinds of stuff like that. So these are some of the expectations we've had with general apps. And we're going to talk about how this kind of differs from the web's general model and then how the web is kind of moving forward. So first, regarding native hardware, native applications have the ability to talk to like the Bluetooth, the GPS radio, access location services, user media. So this is camera, microphone, all kinds of user input, pretty much anything. And of course, storage. It's common for native applications to be able to download things and cache things independently of other applications, and it's kind of like its own root or folder location separated from the other apps. So I have a quick example of some of these things. Offline, this is the Slack app for mobile. You can see I'm in airplane mode and it works offline. This makes sense when we downloaded a big, heavy megabytes on megabytes bundle that contains all the UI elements and the scaffolding. I can click the menu. It's completely functional offline. And it even has some logic included where it tells us, hey, we're offline, and a little button basically saying, like, do you want to try for the network connection and stuff like that. And so not only do we get like the basic user experience in the app shell, but we also get some usable content. So this stuff has been cached independently away from the network, so I can actually see a message that I sent myself regardless of the network connection. So I could just go on the app, check old things out, open the menu, see my previous channels that have been entered and stuff like that. It's going to know about the state of the world without the internet connection. Of course, we see push notifications. These are really common on mobile. An easy way to re-engage with the application without actually being in the app. So, yeah, and this makes sense. I mean, this is pretty common on desktop and mobile in all kinds of native applications. Furthermore, this is more so new, I guess. We've seen pretty interactive push notifications as well, where we can be productive with the application away from the application. So not only do we have to, or we can avoid going to the home screen and clicking on the app, but we can actually do this stuff with native operating system integrations, like in this case, an interactive push notification. And of course, we expect applications to have pretty good real estate. So we expect them to be, as I said, in the start menu, the app tray, the desktop, the home screen, easily locatable because we've downloaded the content, we've installed it, it exists on our device, and that's it. So these are just a quick recap of this section. Yeah, I mean, this is kind of some of the stuff that we've expected native applications on both desktop and mobile to bring with them. Good hardware integration, offline, push notifications, home screen. And we're going to talk about all these different features and how they relate to the web. Right now the boxes are unchecked because historically the web was not built for a model that can support a lot of these features. But we're going to slowly check in some of these boxes as we go, and we're going to see how to actually implement some of these things. But the reason the boxes are unchecked right now is because originally and historically the web was just not built for apps. It doesn't really have an application model. The idea of the web is you have independent pages with links on them, and a link click is going to trigger an entire page refresh. And so we're not going to be saving content or having just the idea of like a shell or a model or something like that. We're getting full page refreshes because the app was pretty much never had this idea of a shell. It was just pages and links. It was great for text displaying and parsing, so that's what HTML got us. And it was really nice for some basic styles and CSS. And we also had basic interactive content with JavaScript. But I really want to stress basic with the interactive content here because we can interact with an app only so much. I mean, JavaScript is pretty nice and allows us to touch kind of the world inside of our app pretty well, but it runs in this kind of bubble, this little runtime inside the browser. So it doesn't really have too much native operating system integration, whereas the native applications built in Java, Objective-C, and Swift and things like that are going to kind of get some of those low-level functionalities for free. So it's important to stress basic here. We can kind of play inside the world of our app, but we can't do too much because the browser sits in between our app and the device. So we have some current solutions to get around this, and we've made some cool looking web apps, and so we're like, all right, let's make them more app-like. And so to simulate some of the features that we talked about earlier, offline, push notifications, and hardware integration, we have a bunch of solutions. So Iconic, for example, I've seen it's pretty good for like taking an Angular application and basically transpiling it into like native mobile UI elements. So you have to build the app only one time, which is ideal, and then it transpiles in a way the application to a native app by basically making web wrappers with like native wrappers around it. And then you can throw this whole bundle in the App Store, download it, and all of a sudden your web content is going to be able to hit any kind of mobile platform or device and just work. React Native, I'm not too familiar with it. I know some people that have used it. It seems to kind of be going at the same goal. PhoneGap. Electron's pretty neat. It's kind of the same idea. Actually, we can see an example of an Electron app. I want to pull up. Yeah. I believe it's Electron at least. Atom here. So if it's an Electron app, so it's just a kind of Chromium wrapped application. If I do Command-Shift-I on Mac, it's actually going to bring up the element inspector. And I can mess with this like I would any regular website. So we can see, if we needed to, it could give us push notifications. It's always going to be there to work offline. And it has nice integrations with the rest of the operating system. And now let's see if I can get this back. I have no idea where my mouse was. Okay. All right. Cool. But all of these solutions, I think, kind of follow the typical trend of web tooling that we've seen. Like things with promises and transpilers that have been around for a while, the platform in some way lacks a little bit. And so we try to make up for this by building tools that kind of exist outside of our app and wrap the application or the tool or the features that we're trying to do in some sort of fix, and then it'll end up working. But eventually the web platform does pick up, and this often means JavaScript becomes more functional and has more tighter integrations with its platforms underneath. And I think this is following kind of the same platform. We're kind of building the tools and hacks like Electron and things like that to wrap our components in something that has a native layer that can talk to the operating system. But if you think about it, this is kind of what the browser does anyways. It is our native wrapper. So we really just need the browser to kind of become a little more powerful. So the web platform's solution to this problem here is going to be progressive web apps. And this is largely going to is the idea of making the browser more powerful so that we can take advantage of some of the toolings that we've seen earlier, but in just native web platform code and HTML, CSS, and JavaScript. So the whole goal of progressive web apps largely is to get feature parity with the native applications that we all know and love on mobile and things like that. And we have to do this through web APIs because that's pretty much how JavaScript can talk to anything. It's this kind of bubbled in environment inside the browser. So we only get what the browser gives us. And the browser has access to all the cool native things. So we just need the browser to kind of give us this stuff. It's because the browser's boss. It's the only thing that pretty much stands in between JavaScript and the operating system. This is a loosely illustrated example. There's obviously a lot more going on underneath, but the idea is we want the browser to become more like an operating system and more powerful, and kind of broker the communication between the developer and the device by releasing APIs and functionality to JavaScript that we can use to talk to the device in ways that the native languages have had for free all the time. So we can get access to some of the really powerful features that browser vendors have implemented in the browser with progressive enhancement. So what's cool is that, again, it's just JavaScript. It's the platform kind of coming back, and we're just using JavaScript, and we're using basic feature detection to kind of give the user a progressively richer experience. So the goal is to use what the browser the work that the browser has done for us to talk to the operating system below. Here's a decent example of this. So we have Navigator, window.navigator object in the browser. There's a geolocation API that has been spec'd and everything, and it gives sort of the web access to your location, or the web app access to your location. So in this case, we're just going to wrap the call to navigator.geolocation in a basic feature detect to see if it exists, if the user agent supports it, and it's up to date, and all kinds of stuff like that. And if it does, we're going to make a call to the getCurrentPosition function on here, which takes a function and does whatever the API does that's specific to it. And in here we can see we're using position.coords.latitude and longitude. So this is what it's going to look like for the code. We're not punishing the user for not having the geolocation, but we're enhancing their experience if they do. And below is the result that the browser is going to show the user. So at this point, when the user sees this, the developer's work is kind of done. It's out of our hands. This is a native prompt that the browser shows the user. Allow block. We can't style this. We can't auto-click buttons like a badass. We can't really do anything cool. It's just up to the user allowing our app to have access to the stuff that the browser has. And with progressive enhancement and really modern APIs, we get some of these boxes checked. For example, the Web Bluetooth API, it's kind of new and it's kind of in the workings, but it's there, which is really cool. We have get user media to get camera and microphone and other user inputs and things like that. Of course, we just all look at basic location services. Me and Noah actually used this at a hackathon, a project that failed badly. And I'm going to give storage a half a check because we've got window.local storage and we have window.session storage, cookies, browser cache, things like that. But it's not really a developer curated cache that we only control. For example, the browser cache is really nice to get multiple requests for the same assets to load quickly, since it's just going to cache it and allow not a full re-download from the server. But things get evicted from the browser cache all the time, like quite regularly. So it's not something we can control. It's not something that we can reliably build an application model off of. So we're going to talk about storage again later. But the three things that are kind of remain unchecked here are offline push notifications and home screen. So these are kind of the big deals to make a web application feel and look native and kind of meet all the requirements that we have naturally set for a native application to meet. And so in order to do this, we have to take a tip from native in explaining ourselves. Basically, the operating system is going to need to know, or the browser in this case, which is going to tell the operating system, it needs to know more about our application in order to support offline push notifications and add to home screen. It needs to know some more metadata about our product. So we see this in native applications. The iOS version is the info.propertylist kind of thing. It's a terribly ugly XML file. I mean, you can see we have a dictionary element, key string, and we talk about, it's got like bundle version and, what is this, bundle development region for the language and product name and all kinds of permission requests and stuff like that. This is kind of upfront telling the operating system, hey, this is what we need, this is what our app needs, this is some information about our app. The equivalent in the Android world is the app manifest. Again, an XML key value pairs file. It's really ugly, and of course it's in a totally different format than the iOS one. So now if you want to build a native app, you have to not only build a totally separate app, but also a totally separate manifest file that pretty much does the same thing. So we kind of need the web equivalent. So the web equivalent for a while has been a giant mess of meta tags that sit in the head element and kind of explain a little bit more about our application to the browser, but it hasn't really taken us too far. So we came up with the web application manifest. And so basically, I mean, it's the closest thing we can get to JavaScript when just trying to talk about key value pairs. That's JSON. Okay, everybody knows JSON probably. We just have a couple things that we're going to upfront tell the operating system, or in this case the browser, which is going to tell the operating system about our app. We got a name, a short name, start URL, display, all kinds of cool things. This is kind of step one to getting our web application installable. You can see we have some things that exist in here that have never been in like meta tags. For example, we've got like the start URL and display and I don't know, background color. I guess the theme color can go in the head or the manifest. But basically, this is going to be enough metadata for the operating system to take our web application, prompt the user to install it to their home screen, and have it work. Almost, though. And in the index.html, we don't have to copy all these meta tags in every kind of header. We can just link it in as we would any file, like a CSS file or something. So in this case, we just do link rel manifest, and we just pull in the manifest file. And so a basic look of the detection is going to be something like this. Hopefully you guys can see that. If you want an example of this, you can go to revolutionuc.com, the hackathon website that I'm building. We have a manifest. We've had a manifest in there for a while. And we can see that in the Chrome DevTools, there's an application tab, which we're going to spend some time in later when we talk about the application that we're going to sort of take offline together. So it just pulls out some basic things like the name, the short name, the theme color, the background color, the start URL, all kinds of stuff, and keeps a list of icons as well. So this is going to be some metadata that the browser can kind of hand off to the operating system. The manifest, what was it, 20 lines or something, really quick. It gets you some nice quick wins and some UI integrations here. So this is on Android, we have the URL bar that is blue. This is as a result of the theme underscore color property in the manifest file, which is pretty cool. I mean, it's widely supported. It like takes absolutely no work, so it's a very progressive thing. I mean, it can work on the platforms that support this kind of stuff. And so we're really close to installable, but to actually get to installable, we need to do a couple more things. We need to analyze some of the common points between offline push notifications and home screen. So we solved the idea of like telling the operating system or telling the browser more about our application so that it can know where to put it and how to launch it and things like that. But we haven't really had still the app model. We haven't really downloaded a bundle of content, installed it, and made sure it's always going to exist without a network connection. And to do this, we use a very recent JavaScript API called Serviceworker. Yeah. So the Serviceworker is pretty instrumental to progressive web apps. It and the manifest is going to make an installable web application. So in this case, here's a quick example of what an installable web application would look like. Flipkart has a really good PWA that they built. And together with a working service worker and a manifest file to kind of upfront explain ourselves, we see a prompt that Chrome on Android gives the user. This is, again, just like the location thing, kind of like a native browser prompt. We don't control when it appears. I do believe we can stop it from showing up if we wanted. But basically, the old heuristics were Chrome had it, I think, pop up. If you had two separate, completely independent navigations to a site that supported these two things, within 5 minutes, it would deem the app as probably useful to you and then prompt you to add it to your home screen. They're probably tweaking that stuff a lot now, but this is what it's going to look like. And then the manifest file is going to give the operating system enough information to generate an icon and a short name, which is going to appear below the application icon on the home screen, a splash screen when it starts up, and pick all the icons out and things like that. So the service worker, as I said, is going to help us kind of maintain that bundle that is going to make sure that our application is going to work regardless of the network conditions. So the service worker is basically used to take our applications offline. By definition, more or less, the service worker, I mean, we could talk semantics and say it's an event-driven client-side proxy that intercepts network requests and responds with a persistent request-response cache, blah, 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 whatever. But there's some pretty cool graphics that I think are neat that I did not draw, by the way. They help explain it. So this is kind of the web as it is right now, right? We request things from the server galaxy up there, and then it goes down the pipe, spits it out at the browser, which is kind of the world down there on the bottom right. With the service worker is an API, is a web worker that sits outside the browser, or sorry, outside of the web page, but inside the browser and away from the server. So it's actually, its job is going to be to intercept network requests from the browser and decide, call an audible pretty much. Do I give it to the network and let the network respond, or can I put it in my cache? And so this is what I was talking about when I said we're going to come back to the storage. Serviceworker has a reliable, developer-curated set of a large cache that we can fill. It's a request-response-based cache that we can put all kinds of things in and manage ourselves. It's going to be persistent and consistent and everything like that. And we'll talk about the Serviceworker lifecycle and how it gets into this position. But the goal of the Serviceworker is to sit in between. It's kind of our server away from home. It can requests go through the Serviceworker before they go to the actual network and outside of our device if a Serviceworker is installed properly and activated. And of course, it can respond directly from the cache, making offline web applications possible, and response is pretty much instant. So how do we get to it? Of course, just like the other APIs we saw, it's going to be progressive enhancement. So if this user doesn't support Serviceworker for some reason, we're not going to punish them. If they do, we're going to augment their experience, possibly making them an installable web application. So the Revolution UC website that I'm building, this is actually an example. So the top line there is just a method, a function name inside of the class that I'm using for the application logic. And I do a basic feature detect if Serviceworker and Navigator, or if Navigator.Serviceworker. I see that written like that a lot. I'm not sure why. I mean, it's going to do the same thing. And if the Serviceworker is supported by this user agent, then we register the Serviceworker. And so the register function here takes two parameters. It's a string and an object. So the string is the relative location of the Serviceworker file. So again, it's a JavaScript file that we write. It's just a web worker that's going to exist outside the scope of the page. And then the object that we pass in has a couple of properties we can throw on it. I think the only required one is scope. And that's going to basically tell the browser from what URL down can this Serviceworker control pages, because it's a pretty big deal that it can just intercept network requests. So we're in this case, the Serviceworker is going to be at origin.com/sw.js, and it's going to control everything from /forward. So anything under this origin is going to be controlled by this Serviceworker. And the Serviceworker file, I mean, this is pretty much the most basic Serviceworker you can write that doesn't function. Once it's installed and activated, you'll see this logged in the dev tools if this was your Serviceworker file and you had a valid registration and everything. So the Serviceworker is entirely event-driven. We're going to talk about some of the events now. So if you've ever messed with web workers, the self keyword is just going to be a reference to kind of itself. It's like this almost. And of course, we can add event listeners to it. The three events that are kind of key to this are the install, activate, and the fetch events. So this kind of goes into the Serviceworker lifecycle, which we're going to cover, but not too much because it's kind of complex, and this is more of an intro to progressive web apps kind of talk. Basically, that one picture with all the pipes with no Serviceworker, that was kind of how it would look if the Serviceworker was installed. We request the Serviceworker, which comes down the pipes. We install it, and it sits on the side, but it's not ready to take over a page yet. It's only ready to take over pages and actually intercept and respond to requests if it's been activated. Now, if I want to have, say I make a change to the Serviceworker file, and I want a new Serviceworker to start controlling this page. Well, I'm going to have one that's already activated, and I'm going to call my other one down the pipes. I'm going to install it, and it's going to kind of wait for the other one to go away, which means wait for the user to navigate away from that page and all pages that are on that Serviceworker to kind of just close. We can call self.skipWaiting in the install event to just kind of push it right into activate, and then that's going to make the Serviceworker definitely control that tab. But if we have multiple tabs to that page, then if we want all those tabs to be controlled by this new Serviceworker, we're going to have to call self.clients.claim in the activate event. But before I go on any further, I want to talk about the event object that we get passed into our callback function. So we have event.waitUntil and event.respondWith. We can see that in the install, activate, and fetch events. So the Serviceworker is this little kind of bug that is going to still be running after I close the web page if I've registered it for this web page. It's kind of like a browser back-end process that's going to always be running. And so if we have a lot of sites that have registered service workers, the browser is going to try to be as efficient as possible and shut down service workers at will to conserve memory and energy and things like that. So if we needed a valid install event for the service worker to ever be activated. So we're going to say event.waitUntil, which is basically going to say, hey, browser, don't totally shut me down quite yet. Just wait until this thing's done. And then if you need to shut me down and spin me back up later, then do it. But if the install event fails, then it's never going to be activated, and that service worker will never control pages. So we say event.waitUntil to keep the service worker, to guarantee that it's going to stay alive for the remainder of that event. So we do that in the install and activate events. Then we have event.respondWith. This is, it's kind of like the idea of returning. So in this case, the fetch event is going to get triggered when your page requests any content from the internet. So whether the HTML parser comes across a CSS file and says, oh yeah, we need this, let's download it, it's going to go through your service worker if it's been activated. If you make a AJAX call or like a fetch call in the console or something like that, it's going to go through the service worker as well. All your JavaScript asynchronous content that's going to be downloaded, it's going to go through the service worker's fetch event. And the fetch event allows us to respond with something. So we could do a simple pass-through by saying event.respondWith fetch event.request. So event.request is the request that we're trying to get from the network. And event.respondWith takes either a response or a promise that resolves to a response, which is what fetch does. So this is going to be a totally simple pass-through. The service worker is going to, the fetch event's going to be triggered. It's going to get the request, and we're just going to actually fetch the request online, and then we're going to respond with the result of that. We can't say return in here to return that data, because that's just going to stop the execution flow of that function. So we have to use event.respondWith in this case. So that's kind of like the basics of the service worker events, and the lifecycle can be a little confusing, so we're not going to totally cover it and how to like get around it and like work with it well. But we are going to start building a basic app. So I want to talk about the app that I'm going to have you guys clone down before we actually start building it. And it's a basic single-page application that we're going to take offline. But I built a really simple single-page app just because that's like the style of a lot of frameworks. It's kind of one step closer to like the application model. The idea is that we want to download the chroming and the frame and the UI elements one time, and then any subsequent requests made inside that page, we don't want to do a whole page refresh and stuff like that. We just want to swap in some dynamic content with like asynchronously. So we'll do like an XHR or like a fetch in the back, and then just move in content to the body. So we're not triggering an entire page refresh. This is like a pretty common pattern to get us closer to like an application model. But of course, it doesn't work offline until we use a service worker. So the application model, so this site is, we're going to walk through the code briefly before we start actually making it work offline and things like that. But if you guys want to clone the PWA meetup simple application, then go ahead and do that, and then we can start talking. While you guys are downloading, I'll just kind of talk a little bit, I guess. So one problem that I kind of have with single-page applications is that it requires us to do 2 round trips often. Usually it does. So we'll usually download the, I'm trying to think without having the code up, but I guess. So we usually go to the server and request like the main HTML file and the CSS that's kind of going to build the UI elements that we want up. And we request some JavaScript as well. The JavaScript is going to come down to the client, and it's going to look at the URL and say, oh, okay, we're on / or we're on /about. Okay, let's get the about dynamic content or just the root dynamic content. And then it's going to go to the server and request some of that dynamic content. So the problem with some of the single-page app models with like routers and stuff like that is that we're making 2 round trips just to get like useful content to the client. So some frameworks like Angular and React, they've kind of begun mitigating this by adding server-side rendering to their framework so that they can build things. Okay, I'm going to actually, so that they can build the entire layout of the site on the server, ship that down to the client, and then subsequent requests can be taken over by the JavaScript. So now we don't have to do 2 round trips. We do 1, and then we handle all the subsequent requests with the JavaScript that we pulled down originally. So I'm going to unmirror this screen, and I can pull some stuff up. So let's see. Have people cloned it? Mostly got it. Cool. Okay. Okay, I've mirrored these. All right. So let's just talk about this app. So it has some branches to it. that we're going to go over. I was going to memorize the code for all these branches and then walk through it and then have you guys sync up to me, and then I just didn't have time to do it. So all the branches are done. We're just going to kind of go through the branches, run the results, check them out in the browser, see the changes that we make, and then, I mean, this is the point where I want you guys to ask any questions that you have and stuff like that, because a lot of this isn't going to be totally obvious with the service worker stuff, because it's a pretty new concept. Yeah. Oh, yeah, sure. Is it good? One more? Does it need to be bigger at all? Is this good? I guess we're going to spend more time in the code here, so let's check this out. Can people see this? This is kind of the importance. Yeah, cool. All right, so I'm going to run this. It has some branches. Let's check out the branches, though. So we have the pre-progressive web app branch, the manifest branch, whatever, this or that. And we're going to just kind of walk through this and see how progressively we're turning this into a progressive web app. Haha. So yeah, npm install, npm start. I'm just going to run this in the browser real fast. And so here's what the application is doing. I want to go to the network tab to kind of explain what this is doing better. So I'm going to do a page refresh here. Just Command R. So first we talk to localhost, just the root, HTML. We pull down, so this here, actually, this home stuff here, this is all just in a main tag in HTML. So we pull down an empty main with a class mute. This is just something that I did in CSS to basically display nothing. We pull down, yeah, pwa.svg. I don't know why the styles aren't showing up, but the styles are here. And then app.js. App.js, when it runs, actually goes to the back end and says, hey, we're on the root. I need the root partial. So it goes and it makes this request for this dynamic kind of data that we have here and injects it into the content. And to make this, so we can kind of feel the burn of some modern single-page application frameworks and their downfalls, I put an artificial delay on the server when it responds to anything with the partial query parameter on it. So in this case, localhost runs pretty quick, and we get the framing and everything, but everything $partial takes a while. So when I go to the about page, it takes a little bit. I think it's exactly a second on the server. And this is just to simulate, if the user has a really slow network connection, or in a lot of cases, since this is a really lightweight app, if we have a big time heavy framework that we're using, it might take a while for the JavaScript to be parsed and evaluated and actually running. And so this is going to kind of allow us to feel the burn of some modern single-page application frameworks that are not augmented with server-side rendering. And we're going to see how taking it offline really is going to make a big difference. So is everybody kind of clear just with the basic mechanics of this app? We can start taking it offline then. So the first thing I want to cover in here is, so we're in the kind of the vanilla branch, and I want to check out the manifest branch, okay? So this is really simple. And like I said, 20-some lines of manifest. We get some quick wins. So I'm going to go in the code here. And inside the public, which is where pretty much everything public is going to exist. I don't know why images is here. That seems odd. Okay, we have a manifest.json file. And so I have, in my JavaScript, I have this serving static content from the root. So it's not really /public/manifest.json. It's just going to be slash. Everything in here is going to be aliased to slash. So manifest.json, really simple. It's going to look like this. I have all kinds of icons in here, in the icon array here. I think you only need, at very least, a 192 by 192 one, and you can check out the web app manifest spec and things like that. But let's just look at some of the keys. We have a full name, Progressive Web App Meetup, a short name. So this is what's going to be used if the application is added to the home screen on a device. This is what's going to be displaying on the home screen. A start URL. So this means when the application is launched from like the home screen or something like that, the start URL is just going to say start at slash. We could say /mobile or /register if I wanted the mobile to give us the register stuff first. But we're just going to have it start at the root. And if we wanted to do some kind of analytics tracking, we could say like $home screen, so that we can possibly keep track in the back end of like how many accesses do we have from the home screen. Stuff like that. So I have seen people do that in examples. The display property is pretty cool. It takes a couple different things. I like standalone and full screen the best. So standalone is going to say when this is launched from the home screen, don't put any browser chroming at all. I don't want to see the URL bar. I never want to touch the URL bar, the browser, the bookmarks bar, settings, all kinds of stuff like that. It's going to be just like a native application, how a native app is launched. We see the status bar of the operating system up top, but that's about it. And then of course we have the full screen option. I wish I had a mobile phone, like an Android, with me that I could kind of plug in and show you, but you could toy around with this if you wanted. The full screen is just going to, we already get full screen privileges by making a progressive web app installable, and that's just going to block even the status bar on top and everything. Okay, background color, this is going to be used for the splash screen on mobile when it started. Theme colors for that browser UI, so if this was launched in the browser, we can, and like not from the home screen, we could say, oh, let's get a little nicer user interface integration here. The description, I'm not even sure where that goes. Probably just going to do what a meta tag does. And then we've got the icons array. I typically put all kinds of icons in here. I think, so these are kind of like the standard sizes, 512, 192, 168, whatever. I usually generate as much as I can. The browser is going to pick which ones to use at which time, so like which icon to use and the add to home screen banner, which icon to use on the home screen, which icon to use for the splash screen, stuff like that. So I just give it the best that I can for the most options. Whoops. So now let's just run it and see what that looks like in the browser. So I'm going to go to the Application tab in Chrome. So we kind of did step one here, and I'm going to refresh the page. So the Application tab is pretty cool because it tells us about the manifest, the service worker, and all kinds of storage. So in this case, yeah, we're identifying the manifest, and it's going to give us the list of the icons I've made and kind of some of the properties that we put in. We can do this. We can click this Add to Home Screen. Is this too small? Is that? It looks a little small. Can people see it? It's good. Okay. We can click this Add to Home Screen button, which is kind of let us know whether the app is like good enough as far as the browser standards go to be added to home screen. I click it. It yells at me. Okay, so we don't have a service worker. Okay, so it first actually checks for the manifest. If the manifest is valid, it looks for the service worker. And in this case, we don't have one. So it's going to say you need a service worker. You may need to reload the page to check that the service worker for the current page also controls. So this is just kind of some nuances with the service worker lifecycle. It's not going to be activated the first time we download it, so maybe refresh the page. But now we can move on to the next branch. So we can see we've got a valid manifest, and it likes that we have a good manifest. It just doesn't like that we don't have a service worker. So we can do some of the basics. Oh gosh. Okay, add SW. Yeah, so in this case, I'll just run it, but we'll look at the code first. So I have this right below the manifest in the root, sw.js. It's a pretty common name. This is basically what we saw earlier, right? The basic install event, basic activate event, basic fetch event, stuff like that. I want to talk a little bit about this version. So if I want to make a change to this service worker and have my new, say I wrote a bug in the first one and I want this new service worker to start controlling pages, it's only going to be re-downloaded if it's not byte equivalent to the one that's already downloaded. So it'll do some checks, really efficient checks, but we have to make the service worker not byte equivalent to the old one, so it actually triggers a re-download and then can go through the skip waiting and the claiming process. So it's common for really simple service workers to, okay, boom, now it's not byte equivalent. Now we're technically going to get version 2. Yeah, and it's going to download the new service worker, and this is going to differentiate it from the old one, and that's why it's going to be downloaded. Some tools that, like Google has a couple, SW Precache and SW Toolbox. They've made like little tools that kind of watch the files that you want to cache in your service worker, which we'll cover later, and generate hashes from them, and then put the hashes inside the service worker, so that when the file changes, the hash changes in the service worker is not byte equivalent, forces a re-download. Kind of a clever way to do that, but this is what you'd need for like a really basic one if you want to trigger a change. And then I think in my app.js, yeah, so I have a register service worker function. This is what we saw on the slides. If it exists, I just log something, and then we just register it. So now this is running, yeah, okay. So if I do a refresh, let's go to the Service Worker tab. We have no Service Worker right now. I do a refresh, and we can see it has been installed, it has been activated, and it's now running. It's probably a good idea, since we're not going to be making, oh, I guess we are going to be making changes to the Service Worker, but to make it the new ones that we're going to write come into effect quicker, we can just update on reload, which is going to download the new Service Worker, put it through the installation and activation steps, no matter whether it's changed or not. And it's just going to force it to go through these steps. So we have a Service Worker. Now if I go to the manifest and I say add to home screen, it's actually going to be okay with that, right? It's going to like it. This is kind of unfortunate, because just having a totally dead Service Worker like that doesn't mean that we can do anything offline. So the browsers are actually going to start changing that to check your Service Worker to make sure that it does actually serve content on the start URL of the manifest. Right now you can just write a dead Service Worker just to have a progressive web app if you want. I think actually my site is doing that right now, DomFarolino.com, so it's too lazy to write one. But yeah, it's okay with this because we have the ability to serve content offline, and if I wanted to hit add here, I can add it to my shelf. Stuff like that. Is what we've covered clear so far? Kind of what we're doing? Cool. So the fourth branch here, again, sorry I'm not coding this live. I never had time to actually memorize the stuff that I wrote a while ago. So we can start this and just check out some of the changes here. So in the fourth branch here, we're actually going to start doing some offline stuff. We're not just going to have a dead Service Worker. We're going to start serving offline content. So we can check out the code. Nothing here changes. But the Service Worker is totally different, really. So what I have is here an array called static assets. This is going to be some of the assets that up front I want to cache off the bat. And we're going to use this array a little bit later on. So I just want to look at the application tab real fast. You can see this cache storage. This is what I was talking about earlier when I said the Service Worker has its own cache that it brings with it. So this is the table of requests and responses that we're going to actually be using to serve content offline. So in this case, we want to wrap pretty much everything here in an event.waitUntil, just in case. We want to open up a cache. So this cache's API is given to us. And I'm just going to open up static 1. And I'm given access to the cache. And cache.addAll takes an array of strings that have the relative URLs to the assets that should be cached. So in this case, I'm going to cache whatever is at root, whatever is at master.css, my app.js, and my progressive web app little SVG picture. So this is kind of be the basic stuff that I need to actually serve content offline. Well, sort of. So we have to actually serve it offline. This is what we do in the fetch event. So there's a strategy. There's all kinds of different offline strategies. One of them that I like a lot is the stale while revalidate strategy. So we've added all this stuff to the Service Worker cache. But now what we want to do is every time the Service Worker gets a request, we want to see if the associated response that would be returned is in the cache, and if it is, just return it no matter what. But then we always want to go to the network and see if a newer version has been found, and then put that in the cache. So at least the next time they request it, they'll be given the freshest content they can. But the first time they request it, they're just going to be given the fastest from the cache. You could also, if it has been updated successfully from the network, and you put a new version of it in the cache, you could send a message back to the main thread and have like a toast pop saying, hey, this application is refreshed. Refresh your browser to see the latest changes. Google Drive does this, stuff like that. So basically, we want to have two promises and we want to race them. So we want the cached response, given some request, we want to get the fastest of the two, caches and the network response. So we say caches.match, which takes in a request and matches it with a response, if it exists, undefined if it doesn't, and fetch event.request. Both of these are going to return promises. So we have the cache promises and the network promise. And we want to return a promise to the user. And okay, so the next branch we're going to be doing more of the stale while revalidate stuff where we're actually putting more things into the cache. But right now we're just serving from the quickest. So for those who don't know, promise.race takes an array of promises and returns whichever fulfills first. So I saw this in an example and thought it was kind of neat, but it doesn't return the one that resolves first, it returns the one that fulfills first, so resolves or rejects, which is why we kind of have a little then catch little mess here. So I say, okay, either the cache response or the network response returned first here, fulfilled successfully or unsuccessfully. So if it returned successfully, usually that's going to be the cache. Then I want to say, okay, we're going to return the response from the cache if it's there, or if it doesn't, if it wasn't there, so it returned really fast and it returned with undefined because it never was in the cache, then we just want to return the network response instead. So we basically say, if the cache didn't work out, return the network response, which is from fetch. When fetch fails or hits like a 404 or something, so like if we're offline, it's actually not, so it's going to return a rejected promise. So we're not going to be able to handle it in then, which is why I have the catch here. So if either network response from here or network response from here fails, we need to catch it and just return the cache response promise regardless. So basically we're saying if the cache didn't work out, then return the fetch promise. If the fetch didn't work out, then return the cache promise. And if they both didn't work out, meaning we do get here and it's still undefined because we would return the cache response here, then there's nothing we can do. It's not in the cache and we are offline, so we have to return just the 404 back to the client. And we want to respond with that promise. Is there any questions about this code? It's a little messy. It might not be super obvious what's going on, but the idea is that we want to return the fastest, and that's either going to be the cache response or the network. If it's not the cache, we try the network. If it's not the network, we try the cache. If it's neither, we just return a 404 because that's all we can do at this point. Does that kind of make sense what we're doing? Okay, so in this case, let's go and check out the code. So okay, we are running. So I'm going to do a refresh here, and notice that we have this little arrow up here next to the cache storage. So we can check it out. It opened a cache called static1. We can have all kinds of different cache tables in here. If we click it, we can see our table of requests and responses. So we saw off the bat, just in the installer or activate event, I think it was the install event, we cached root, master, CSS, the image, and the JavaScript file. So basically what that means with our service worker is I should be able to take this site offline. So I'm going to go to the network tab, check the offline box here, and refresh the page. And the site is going to load. Now we never cached the partial that would load here, but we do have a basic scaffolding and user interface that is, like, we're at least owning that we're offline and not just letting the dinosaur kind of take care of things for us. So that works. That's pretty nice. Of course, like none of these are going to cut it. I'm going to go offline and I'm going to request /about. So that's, oh, I'm online, sorry. If I'm offline and request /about, I am still going to get a 404. So you see the service worker returned a 404. Now, the actual server that I wrote is returning the same HTML and CSS on /about, /other, and anything, because we just want the JavaScript on the client to take care of the routing. We're not doing any server-side rendering or anything like that. So even though this is going to be the same HTML that's returned, we never told the service worker, hey, on about, just return what we have cached for root. So we haven't done that yet, so we can't actually do deep linking where we can say /about or /other was the other page. So deep linking fails offline. It does work online because the server knows to just kind of return the same stuff. This is kind of how some single page applications work. Again, it'd be better if it was server-side rendered, but for this simple example, it didn't really matter. And we also know that, so we're making other requests on here. In the network tab, for example, when I refresh, I mean, we're getting some other things. We're getting like Roboto, the font that I'm pulling in, and any other assets from third-party stuff that I haven't cached. So right now we have a cache that kind of works. It works offline, but it's very, very limited. But really quickly, I want to cover what's in here in the network tab. So the user agent makes the local host request here. And then we see all these requests, like with the little cog next to it, the little settings wheel kind of thing. This indicates that it was served, or that the service worker got this request. So you can see, first the browser got localhost, something that I triggered. And then later on, we can see the service worker could respond to localhost and master and the SVG file because these were cached, but it couldn't respond for the font that I was pulling in and some of the other stuff, like the manifest file or whatever. Maybe we are caching that. So anyways, this means that the service worker dealt with it. So pretty much every request we're going to see is going to be duplicated in the DevTools, and it's going to indicate a request that the server or that the browser made, and then a request that the service worker made also. So again, we're not caching anything dynamically. It's not like we're coming across new content and like caching about and caching other. No, I mean, if I go to home and refresh the page offline, we still get the UI, but the dynamic content was never loaded and never refreshed. So we need something like a stale while revalidate strategy, where we can, when we come across new content, also cache it for later visits. And that's pretty much what the 5th branch here does. So we have full offline. So we're going to run through some of the logic that exists. This is just a service worker change. And so we're going to handle some of the routing, and we're also going to handle some of the stale while revalidate logic. So let's check this out. So it's much bigger. So basically, I'm doing a little bit of routing, and this is a developer from, I think, Microsoft termed. So first of all, let's talk about server-side rendering. Single-page applications traditionally kind of serve the same HTML and then let the JavaScript on the client take over for dynamic content. But then they were like, well, we could get faster first renders and better things like that if we use server-side rendering. So we augment the framework to work with server-side rendering. This was called Isomorphic Javascript. We have routing on the client and the server. There was a joke that now we have trisomorphic JavaScript because we handle a little bit of the routing in the service worker as well, because it's the server away from the server, and so it kind of has to act like one. So in this case, I have some really, really simple routing. I just pull the includes function off of a Ray.prototype, and I just say, hey, if the URL that we're requesting includes localhost 8080 in this case, and partial, and does not include dot, so I guess I probably could get rid of that actually. Then we're just going to respond with, so I'm making a new request for the root, and I say, hey, do we have anything in the cache that can be responded with a request from the root? So now on it does not include partial. So for /about, /other, whatever I want, test, whatever, it's always going to serve the root request. So now we kind of enabled deep linking offline, and now we have some other stuff as well. So we still have the cache response and the network response. And I'll talk about this copied response in a bit. And we're still racing like normal. This is all pretty much the exact same code that we've seen. And we want to respond with the return promise. But notice, this isn't a return. I mean, the execution's still going to flow through this function. So we can still have the service worker wait until something. So we're going to wait until, and we're going to open the cache that we have. And I'm going to, let's see, what are we doing? Okay, so the copied response here is going to be just a copy of the network response. And the reason I actually have to make a copy of it, or in this case clone the response, is because responses can only be read once. So if I want to read a response twice, I have to clone it and then read the other copy of it. So it's kind of just a little response nuance here. But you can treat this everywhere you see copied response in your mind as like basically what the network response is. So down here I'm opening the cache, and I'm saying, okay, when copied response fulfills, which is really the network response, I'm going to just put something into the cache. I'm going to put that request, and I'm going to put its associated response in. So this is going to allow us to kind of update our cache as files change, and also cache new things, so like fonts and other things like that. You'd want more strict guidelines on what dynamic content you're actually caching and things like that. And for some stuff, you might even want to use IndexedDB and things like that. But there are a lot of like heavyweight service worker tools and libraries to kind of help you determine more of that. So in this really trivial example, we're just showing the basics of stale while revalidate. So is everyone kind of, are you clear on what this is doing? The goal is that we want to take new requests and throw them in the cache as well, so that we can just keep building our cache progressively as the user visits more of our application, and we can serve more of it offline as they continue. And of course, this is still going to be nothing compared to native application bundles, megabytes on megabytes on megabytes. This is just kilobytes on kilobytes on kilobytes. We can, okay, so this is running. Let's go ahead and test it. So I did a page refresh. Okay, that was interesting. I'm just going to go ahead and clear the cache. I end up using this button a lot. Just to clear the cache, reset the service worker, wipe everything pretty much, start from scratch. Okay, where are we? Okay, it doesn't like it. Let's try this again. I didn't have any problems earlier. The font seems a little weird to me. Oh, I'm actually not on the internet. That's why. Okay, well I haven't done that yet, so that's fine. We don't have to do that. That would make sense. I never actually connected to the Wi-Fi. So like we said, I've already visited this page with the service worker working, right? And so this dynamic content was loaded. So if I check the cache, I refresh, and I check out the cache, I should see some more stuff in here. So in this case, I see the root request, which is what we statically cached off the bat. We knew this is the bare minimum that our bundle, that our application needed to run offline. And then I visited partial, so my service worker was like, hey, well, I'll just throw this in the cache as well. And so now if I visit, if I visit like other pages, like about, and things like that, and other, I think you have to refresh the page for this to show. Yeah, so now we can see, hopefully this is kind of clear, or you can at least see it on your screen. We get the about partial, the other partial down here, and about, and things like that. So now we have all these partials loaded, and sort of our deep linking setup. We can actually go offline, so it's not going to be connected to the server. I can do a refresh on other. I can do a refresh on about. Oh, I never visited about when I was online, so it's not going to like that. But the point is now I'm offline, and I can still ask for content like other, about, and home. And you see this is instant because the artificial delay that I put on the server to respond with partials is gone because it's now in the cache. So the service worker is going to respond to this stuff immediately, and everything that needs a real internet request is just going to die out since I'm not actually connected to the Wi-Fi here. But that's pretty cool because that artificial request, even when I'm online, is just gone. This content loads immediately, about, other, and home. But what's also really cool is that we can see kind of the effects of this if I want to change a partial. So I have a partials folder in my public here, and I can change index, and let's say a lot of homes for our dynamic home content. So the app here, the app's just right here running. I've not refreshed the page. I'll go to about and other and visit some things. And I'll go to home. This means the service worker requested home, but it also went to the network. So it did get a changed version and put the lot of homes version into the cache. So if I go to about and then back to home, we'll see the latest content. And we still see no delay because it dealt with the delay in the wait until when that fetch was resolving. And I can, of course, go ahead and change that back. And we can go back to other, home, and then if I go somewhere else, we could say on this request if we wanted to trigger a toast or something, hey, this content has been updated, refresh your page. Refresh the page. Now we get the latest that has been revalidated after we served the stale version. And you can see that artificial request is just completely gone, offline and offline, or online and offline. We have deep linking enabled. We're totally offline, and the application will serve content and keep itself updated with the service worker as well as the dynamic content. So that's pretty much it. Oh, I just opened Canary. Yeah, hopefully that was helpful. A little review about the service worker and progressive web app features and things like that. If there's any questions, just ask them, I guess. Just raise your hand. I can try to answer them. I'm not super knowledgeable, but I'll do my best. If you need help with anything or you want to know more about this, I can probably post some good resources to follow up with in the Slack or something like that. There's a lot of things that we didn't cover that are specific to service workers are a huge topic. What's up, Noah?
What's the browser support
on Service Worker? Yeah. I believe Mozilla has Service Worker implemented properly. Chrome, Opera, I think all of those have mobile as well. Apple, not at all. So Safari, I'm pretty sure Safari on desktop and mobile, and Chrome on mobile on iOS, because iOS just will not allow the browser to have that much control of the background service worker running and accepting push notifications and stuff. It's kind of, it makes the browser more like an operating system and more invasive, and probably would damage the App Store a little bit. So they decided not, I mean, it's in their 5-year plan, and they're showing some positive signals to it, which is, I mean, 5 years is a long time, but they've started to implement Fetch, which we saw. This is like the XHR alternative, and Fetch is pretty much, you can't have a service worker without Fetch. My guess is that they're going to start making some moves in the web advertising business before they kind of unleash this beast on iOS. Maybe not, but I think it can't really help them too much if they didn't have any foot in that kind of business before doing that. So yeah, push notifications, progressive web apps, service workers, totally dead on iOS and yeah, Mac OS operating systems, Safari, Chrome on iOS, things like that. Yes?
Rather than showing an overview, like, hey, there's new content available, could you also like wait for the network request to resolve successfully and then serve that instead of the category?
Oh, so you're saying actually hold up
Yeah.
and then serve? Yeah,
That'd be better. I don't know.
you could do it. I wouldn't say it'd be better, because then it's yeah, it's. I mean, you could definitely do it. Yeah, you could work it so that the UI. So the only issue with that is that means every single request you make is going to have to wait until the server said it's cool before. So you're never going to be using the cache for dynamic content, which means that artificial delay I put is going to be really, really, really nasty here. And we're never actually using the content or the cache for dynamic content. Of course, you could do it, but it's not. I would not say it's ideal. Any questions, comments? Yeah.
So, in comparison, like, what do you think is lagging behind on PWAs that's stopping it from taking over everything native?
I think there's some integrations that just are not done yet. I mean, like, the browser can't do everything that native can right now and give web developers access to everything that native apps can do. So like, there's the idea of like, will progressive web apps be able to completely overtake native apps? And some people say yes, some people say no. It just depends on how deeply the browser can be integrated with that stuff and how much control we can give the developers through JavaScript. So I don't really, yeah, I mean, the holdup is probably because it's like a somewhat new topic and people just aren't developing them enough. And also there's just a lack of functionality. I mean, it's kind of like a step forward into, native feeling applications, but they're not as functional or as married to the device as a native app will be yet. I think we'll probably see that change with a lot of new web APIs coming out and things like that, but I don't know if it'll ever, completely be able to overtake native. I think in the long-term future it will, but I'm not sure. So.
Are you able to get push notifications on mobile?
Yeah, you can do push notifications on everything except for iOS. I didn't really cover that too much. Yeah, the push notifications is live up, Noah? Oh, we'll check. Oh, I'm not on the internet. That's great. Well, there's a. Yeah, well, no, but the repository exists. We have so for Revolution, you see the hackathon. We had push notifications integrated in the application, and so if it's like github.com/ I'll just type it out. If you want to see an example. github.com/ revolution UC live. It's a basic app that has push notifications with its service worker. Yeah, so you can do native push notifications on mobile, on desktop, pretty much anything that supports service worker. I mean, you don't support service worker if you don't support all of service worker kind of deal. And there's a lot of other things we didn't cover. So push notifications are kind of a big deal. You actually need a backend to kind of sync with that, and so you can have like a sending ID key and stuff like that. And there's a lot of security that goes with it. Service worker, I mean, it can intercept network requests, and it's kind of a big deal. So it can only be actually activated on sites served over HTTPS, which is the same with a lot of modern web APIs. I think Web Bluetooth is that way. Same with navigator.geolocation, which is what we saw. I think that only works over HTTPS. So push notifications are really cool. And there's also something called background sync that we didn't cover, and it's really neat. It basically, imagine like a messaging app where like it's in the web and you want to send a message, so you like type it out and you hit send, but you don't have any network connection. What's the app going to do? Like a native app could probably handle that, cache it, and say, hey, when I come back online, we'll send it. A web app traditionally would just be like, would just kind of die and be like, sorry, I can't do it, and like the user would not be able to move forward with that. Background sync allows that, like the code to be run as if you were online pretty much, and register like a queue, like a task in the service worker to say, hey, when we come back online, spin up and then handle this queue of network requests that the user meant to make when they were offline. Background sync is pretty cool. Background fetch is really cool. Downloadable content in the background. Serviceworker is really powerful, and some of the APIs are complex. Push notifications is really neat. The examples are pretty complex as well. I have a, well, yeah, so this is a decent example of an application with push notifications. It's a little rough. We built it in like 2 days, like if that. A couple nights before the hackathon started, but it was a cool project. What's that? Well, it'll only intercept requests from that page. So like if I register the service worker with revolutiongc.com, then it's only going to intercept requests on that browser from revolutiongc.com/forward. So yeah, no, it's not. It's not like no. It's not like everything. You register for an origin, and then the browser keeps track of all that. And so that's about as secure as it's getting. But I mean, it makes sense because your code is controlling your requests. So it's pretty safe.
Just following up on that though, like your code could make requests itself to trigger a service worker, right? Like let's say I'm a malicious programmer and you've come to my website and now I can start spawning off service workers to do Bitcoin mining on your phone for me. So that might be why some vendors are not so keen on just shipping. Allow users to run arbitrary JavaScript.
Yeah, that makes sense.
Yeah. That makes sense. We're not everyone's a good person.
Just us. Any other questions, comments?